technology is that it has a very short retention time, and that saves us quite a lot of space, but also is a very efficient in terms of time and space. So let me invite Mr. Urban to present and talk about ED Biogas as a company and also about the technology. Urban, over to you.
Yes. Thank you for this invitation to the webinar. My name is Urban Frenderson, and I'm representing the company ED Biogas. Just do a sound check that you can hear me. Hello?
Yes,
hello?
Mr. Urban, we can hear you.
Yeah, very good. Just checking. Some years ago, we looked at biogas as a resource out of waste, and we found out that you can do biogas out of very many things, organic materials and so on. But our interest is to make biogas out of waste, organic waste to energy. That's our solution, how to do it. And in a couple of years we have invented this solution from the reactor to make more gas faster. And you need to have a fast producing gas reactor when you are running electricity producing, because you need so much gas to do it. And we also invented that the reactor must be mobile, so that we can manufacture it and do place it at site and have it up running in a short time. That's our interest to how to do it. And we looked also for how to do the gas. And we can see that you have to have very good technology when you do the biogas, because if you have less fat or less carbohydrates when you do it, you don't get so much gas out of the technique. But our invention for how to do this, we have made a scalable reactor that you can have it from small size to big size. But if you really want to make electricity or make fuel gas out of it, you have to have a reactor who is producing very much gas for feeding or a motor or micro turbine, or how to feed the fuel. I have very low loudness by me. Could you perhaps raise this thing?
Mr. Urban, can you have your screen as full screen, sir?
Yeah, I have it. But I can nearly hear you. It's very loud. The loudness is not enough.
Okay, but we can hear you clearly, sir. That is okay.
Okay,
can you maximize your screen? Can you have your screen as full screen?
Yes, yes. But
Yes, sir. You can.
Yeah,
yes,
we try again.
Okay, sir. Okay.
Yes. What we are presenting for India is in the moment the big reactor from 120 cubic meters, and we can use the organics waste that we like to have in this thing. It's we can use the manure, sewage sludge, we can use food waste, slaughtering waste, agriculture crops, or waste from householding or from farming. That's what we like to do the gas out of. And the traditional problems you have in a reactor or when you make the gas is that you have sedimentation or foam cover problems. And you also have normally health and biological problems with this waste. And what we have done, we are using the 55 degrees centigrade spectra when we do the gas, and therefore we also have a thermophilic operation, and we're reducing salmonella and everything from bacterial when we go over 50 degrees. And we don't have so much smell out of this thing, and the process is anaerobic. We also like to take a lot of water away. In our normal process we take 80% of the water away because the water won't give you any gas. So we have much more dryness in our process to make the gas out of. And how our reactor is working, as I said, we have an anaerobic process, and you have to have very good order when you do the gas. You have the first step you need to make sure that it's working is a hydrolysis step. Carbohydrates pass into sugar, and grease into fatty acid, and proteins pass into amino acids, and that you have to have that to start with, otherwise you don't proceed doing this process. In the second step, you have to have the acidogenic steps, and germs will break down sugar into alcohol, fatty acids into simple fat, and amino acids partly into ammonia. And in the third steps, we have the acetogenic steps processing charge to acetic acid, carbon dioxide, and hydrogen. And to the fourth step, when you have methanogenic step, acetic acid, and carbon dioxide interact with alcohol and grease and create methane and carbon dioxide and smaller amount of sulfur, hydrogen, and ammonia. And we have very good order in our reactor how to manage those things through the reactor, and therefore we have a very high producing reactor, and we can produce process cycle in the reactor is from 8 to 12 days, and the reactor processes 9 to 14 cubic meters of substrate per 24 hours. So we can, from a year, process approximately 3,500 to 5,000 cubic meters substrate, and this substrate we have taken 80% of the water away, so you have to multiply from a normal wastewater plant. We can multiply those 5,000 cubic meters with 5, so we process approximately 25,000 cubic meters substrate a year in the reactor, and the substrate have a dry solid containing from 4 to 12% when we do it. And depending on substrate energy, we can get out from 1 to 3 million kilowatt hours per year out of this thing. Thanks to capacity for higher dry solid contents, continuous flow from 8 to 12 days, and other features, we have a very good efficiency in this thing, and it's up to 7 times more than traditional biogas plants. So our main purpose it is to produce as much gas as possible to run the if you have an electric producer or to produce fuel gas. And in those features we have the system for pre-hydrolysis before this thing, and we also use dewatering systems to make the right dry solid or dryness in the reactor when we do
Hello, Urban.
Yes, hello.
Just to interrupt, this is Sandeep here. Could
Yes.
you please put on the presentation that you are presenting right now? Could you please maximize the screen, because we are the audience is seeing only one slide.
Okay. I don't really know how to do that, but I can. You see only the first slide, the Swedish Biogas experience.
Yes. Yes.
Yes.
Could you please go to the slide which you are presenting right now?
Yes.
And could you please maximize the screen?
I can see how we do that. Could you guide me some where to maximize it? I have.
Mr. Urban, it's Shift F5.
Shift 5.
Yeah, Shift and F5. F5 function.
Shift function 5.
Something happening? Is it full screen?
Yes, Mr. Urban, it's full screen.
Okay.
It's in the menu. It's in the menu slide right now.
Yes. We'll try again then.
Yes, sir. It's working.
Yes.
It's working.
Yeah, Swedish Biogas Experience is the companies we're working together with in the water purification, sorting out waste, biogas digester, and gas upgrading. This is the local Our Reactor. It's this 120 cubic meter reactor, and above you can see the collector from biogas. So we have sort of a collector to put it out, and inside we have a sort of a transportation device that makes this thing go through the reactor, and it's working very slowly. It's only tearing one turn 24 hours. So we're just pushing this thing through the reactor, not mixing it. And that's the secret why it's producing so much gas when we don't mix the substrates, just pushing it through, that we have very good order in this anaerobic process. I have to make a break. Yeah, sorry, I'm back. Hello.
Yes, Mr. Urban, we're all here.
Yes. What we do, as I started with this, is we are like to using, this is the demo version of our reactor. It's placed in a container, and we have manure, sewage sludge, food waste, slaughterhouse waste, agriculture crops, and household waste from farming, whatever. All organic waste, that is what we are doing the gas out of. And as I said, the traditional problems when you make gas, it's make the plant profitable when it's mid or small size one, but when we do much more gas in our reactor, we could economize it because we make so much more gas. And we have also the financing from deposit fees for leaving waste, and also we have solved the problems with foam and sedimentation in the reactor. So we have nothing left in the reactor. We don't have any sedimentation problems, and as it is an anaerobic closed process, we don't have any bad smell. We take also the water away, and normally the substrate contains very much water, and you can see in this thing that if you lower the water, you only have much less volume to handle in the reactor. Normally you put in so much water, and you have to heat up the water and so on, and we have reduced this process. This is the thing we do in the reactor. Our equipment for making the substrate go forwards, it takes the foam away from above, and it takes the sludge away, so we don't have any sedimentation. And this thing turns only one turn in 24 hours. And as I explained for you before, the first step, the hydrolysis step, you have to have it. The adogenic step, also the thing you have to do for making gas out of it. Adogenic steps, also number 3, and at last you make the methane gas out of the substrate. And we think we have very good order in our reactor to produce the gas. And as I said, the figures, we have a reactor from 127 cubic meters, but today we are working in a project where we can also use much bigger, that we used big tanks, and using our reactor for pre-hydrolyzation of the substrate, so we can manage much more substrate. Then we do a pre-hydrolyzation of the substrate to get it started, and we take much of the water away before we get into the reactor. And when the gas gets out, we also have a system for dehydrogenation and desulfonation. So before we use the gas for householding or for electricity, take much of the water and the sulf away from the gas, and that saves a lot of engines. If we have solid waste, we can do it another way. Then we have a mill that we are crushing the substrate to use as in the same way as we do for liquid waste. This is just a schematic biogas plant, how we do it. We heat the substrate up in the reactor to use the 55 degrees. But we can also use mesophile way in the reactor. We don't have it, but then we get approximately 30% less gas out of the reactor if we do it without heating. And options for the gas, this if you have a gas engine, and the efficiency from a gas engine is perhaps 30% electricity out of it and 60% heating. We can use a micro turbine, and if you do a life cycle cost analysis from micro turbine, you can see in the long run that you have much more efficiency from micro turbines to make electricity out of it. We can also use a fuel cell to make electricity and heat out of it. We can use it in a boiler to heat up the water, and we can have for domestic and household gas. We can upgrade the gas for methane to fuel, vertical fuel, and we can also make it to hydrogen. And the losses from the gas engine, microturbine fuel cells and boilers are between 10 to 15% in the system. Losses from methane and hydrogen process is approximately 10%. And as I said, we can do it in a mesophilic use and a thermophilic use in the reactor. And the reactor is developed to make as much gas as possible out of it. And therefore you can use it for continuous production of electricity, and also for continuously processing vertical fuel. And as we do the reactor, and we connect the other companies who makes the electricity producing motors, and also how to use the gas in other ways, and or upgrading. And we mean in Sweden we have a regulation that says that if you use the substrate, if you have it 7 days in 50 degrees centigrade or 2 hours 70 degrees centigrade, you have homogenization product that's let out of the reactor. And in our case we have up to 10 days for 55 degrees. So we mean that we have a halogenated product that comes out of the reactor. We also have a supervisory control of this thing. We can support they who runs the equipment from an internet system. If you only have a telephone, we can support the one who runs the reactor, including gas production and any consumption that's given from this thing. And we also have a very good controlling system for this thing. This is SCADA based. And we also have this monitoring pre-treatment system that you can see whatever the reactor is doing. And if we connect an internet, we can also see that, and we can help the staff who's running the equipment. And also the gas system We can see that on screen. And our target customers for this is water treatment plants, pig farms, cow farms, chicken farms, rice farmers, greenhouse, groceries, fruit farmers, household waste, and slaughter waste. There we have some details for connection. When my presentation is over. Mr. Sandeep?
Participants, we request you to type the questions in the chat box and send it so that Mr. Urban can answer the questions. Mr. Urban, we have a first question
Yes.
asking the cost of the reactor.
We are not selling it from Sweden. We like somebody manufacturer to produce it in India. So we are in the moment dealing the price for a up-running plant in India. We have today a license taker in Bangalore, but the prices in what do you say, in US dollar, or in I have to count how much we are intending to sell it for in India, and it depending on what sort of if you have a gas motor, a genset, or if you have a micro turbine or upgrading system for vertical fuels, or just handling the gas for householding. We have to know how much equipment we have to put through in the system for giving you a right answer from the costs of the reactor.
Okay, Mr. Urban. The next question is that now that you already have a licensed partner in India, what are you looking forward to?
We are looking for more. We don't sell the equipment as hardware from Sweden. We are looking for license takers who can develop our reactor in India.
Okay, Mr. Urban. The next question is that is it a plug flow reactor, and what kind of a reactor exactly it is?
Yeah, it is a plug flow reactor. We have a continuous flow from in 120 cubic meters. We do it in 10 days, then we have 12 cubic meters a day of substrate in the reactor.
Okay, and the next question is that what substrate are you focused on?
Waste. You can't you can't use waste, just waste. You have to know what sort of waste you are using when you do the gas. If you have less fat or too much carbohydrate, it's not so good. You have to know the mix for this thing, and therefore we like to have a lab test of the substrate we do it of. Then we can give you an answer how much gas we can get out of it.
All right, Mr. Urban. So the next question is that what substrate have you worked at Sweden?
Household waste and wastewater treatment plant waste. That's we have also tried from pig farming, manure from pig farming, and there we can see we have tried all these things in Sweden, but we don't know the test reports from what's in India, from how much gas we can get out of Indian pig farming or cow farming or household waste. So that's what we are looking for, lab reports for how much gas we can take out of the substrate.
Okay, thank you, Mr. Urban. The next question is asking about the press mud, and can it be used as a substrate?
Please, can I have the question once more?
Can we use press mud as a substrate? Is the next question, sir.
I don't follow you. Press
mud.
Yes, that's organic. Yeah, you can use that for gas production. Yes. I didn't read
right,
your
okay.
word for it first.
Okay. Thank you, sir. Participants, I request you to kindly enter your questions in the chat box and send it to us.
Yeah, I can explain why we don't say that the cost will be this or that for the reactor, because if you are using solid waste, then you have our fraction that we like to have in our reactor is less than 12 millimeter pieces. So we have to have a mill. If you are using waste from some organic material, we like to mill it down to 12 millimeters. But if you have sewage from a wastewater treatment plant, we don't have to mill it to start with. So it's always depending on what sort of equipment we need in the system to do the things of. We can do gas on most products, but the equipment is a little bit different from solid waste to liquid waste, and it's also depending on what you like to do with the gas. If it's for householding, or is it for a gas motor, or for a gas turbine, or for upgrading to vertical fuels. This is a very big difference in what you like to do with the gas.
Okay, thank you, Mr. Urban. The next question is that do you have a gas upgrading system as well?
Yeah, we are working together with NeoCeo, as you can hear a little bit later.
Okay, thank you, sir. Participants, I request you to kindly drop your questions in the chat box below.
We can also say that when we have tried out different substrate, how to get much gas out of it, we can say that if you have, even if you have a good substrate that's not compatible with other things you mix it with, if you do it in the right way, you perhaps get out 5 times more gas than initially if you only use pig farm or from manure from cow farming or something. If you add fat or in this thing, you can carbohydrate, you can make out perhaps 5 times more gas out of it.
Okay. The next question, Mr. Urban, is about the capacities. Right now, do you have only 120 meter cube or any other meter cube capacities available?
No, we can do it. We can do it from 10 cubic meters, and today we are aiming for a reactor from 160 cubic meters. The problem we have that is we like to do it mobile, and I think you have some troubles even in India to travel with a 160 cubic meter reactor. That's the problems. But it's no problem to making them bigger. We can do them 300 cubic meters. The technique is all the same, but to transport it, if we are going to build a reactor from 300 cubic meters, then we have to make it on site.
Okay. Thank you, Mr. Urban. Participants, I request you to kindly drop in your questions at the chat box below. So, Mr. Urban, the next question is, what kind of a partnership model are you looking for?
We're looking for somebody who can manufacture the tanks and our reactor. And the reactor is, if you take 120 cubic meter reactor, is a size of 4 meter wide and 14.5 meter long. We're looking for somebody who can manufacture them, and we're also looking for license takers who can sell the things and also do maintenance. We're looking for companies who can have maintenance for the reactor. It's a very easy process, but it's still, we have to stop a couple of days every year to make maintenance to the reactor, change some bearings or something. Normally we don't have any stops for maintenance, but once a year we like to stop 5 days to ensure that everything is working.
Okay. Thank you, Mr. Urban.
We're also looking for companies who can connect the wiring from electricity and so on from this thing.
Can you throw some light on that, Mr. Urban? What exactly?
Yes. If you don't share the big net for electricity, if you have a local net for electricity production, we're looking for somebody who can make the wiring for the electricity for us. If we place this reactor in a place where you don't have electricity, we can make a local net for electric, and therefore we're looking for somebody who can make us the wiring.
Okay. The next question, Mr. Urban. In your experience, how is the operational cost different from traditional digester?
Yeah, this it's depending how you are counting. If you count per produced kilowatt hour, then we can compare with everybody. But if you only comparing with the investment cost, then there's companies who are cheaper than us. There's no problem.
All right. Thank you, Mr. Urban.
Our system is developed for producing much more gas in the system, just to see that we can run some electric motors or micro turbines in the system for a small unit. That's our design demand.
Okay. Thank you, Mr. Urban. Mr. Urban, the next question is that do you also give supply for people who are interested in procuring the equipment?
Yes. We like to offer an license taker. We have education systems for how to run the equipment, how to mend it, and also how to connect all systems for electricity and controlling it. So we offer a license taker the complete knowledge on how it's running, how to manufacture it. We also have manufacturing drawings for everything, and also education for how to run and connect it. We are not going to raise the plant. It's up to the license taker to take care of a company who can weld this tank together or make it in plastic or wiring systems.
Okay, thank you, Mr. Urban. The next question is that how will it impact the climatic conditions? For example, you have tested in India, in Sweden. How will it affect the gas producing capabilities in India?
Yes, it solves some problems you have with from manure from farming or from wastewater treatment. As I said, we have this system when we do it 55 degrees. We think we have a system where we can use the rest for in the agriculture system or for growing things.
Okay, thank you, Mr. Urban. The next question, Mr. Urban, is how do we maintain the temperature at 55 degrees? Do we have any heating equipment, or how do we maintain the temperature?
Yeah, we can use we can do it in several ways. Normally we're using the cold water from the motor or from the turbine or from the fuel cell, the heat water, the cooling water from this system to heat up the reactor with it. But we can also use sun collectors for heating up the reactor. And in your country you have not so cold weather as we have in Sweden. In winter we can have up to 30 degree minus, and I don't think you have less than 20 degrees plus in India.
Yes. Okay. Thank you, Mr. Urban. So next question, Mr. Urban, can the biogas produced be used in the hot water boilers as in-house consumption?
Yes. Same as LNG.
All right. Mr. Urban, the next question, do you have any installations other than in Sweden?
Oh, we have started to explore the market in Vietnam. So we have a license taker who's we were working with in Vietnam, and now we are trying to get into India.
Okay. Mr. Urban, the next question, do you have any installation in India, or is there any possibility of having an installation in India?
We haven't raised any plants in India, but we are in speaking terms with a couple of companies to do it.
Okay. Thank you, Mr. Urban. Participants, I would request you to kindly type in your questions in the chat box.
You have some more questions?
As of now, we don't have any further questions, Mr. Urban. No. So, thank you for your presentation once again. And any further questions, we'll be writing to you for your clarification.
Yes.
Thank you for the participation, sir.
Yep. Thank you very much.
Yes, hello. So now we have heard about biogas production, but it is really interesting to have with us also Peter Vasilev from NeoZeo. He holds a PhD in inorganic chemistry from Stockholm University and has very deep knowledge in porous materials, structuring of porous material and gas separation technology. And he has accomplished Stockholm School of Entrepreneurship and received international business trainings. He is also co-founder and CEO of NeoZeo, the company and the concept that we are going to just listen into. NeoZeo has developed a fantastic and very efficient technology for upgradation of biogas, raw biogas, and NeoZeo has found in various tests that it is much more beneficial to upgrade the biogas from a pure economic point of view. So let us hear from Peter Vasilev, and let us welcome all to hear his presentation now. Peter, over to you.
Good afternoon, ladies and gentlemen. Can you hear me? Hello?
Yes, Mr. Peter, we can
Hello.
hear you. Hello, Mr.
Okay,
Peter.
very good.
Yes.
Hello. Can you see the slides?
No, Mr. Peter, I'm afraid we are not able to see your slides.
How about now?
Yes, sir. Now we can see your slides.
Everything is clear. You can see a full slide, not a part of slide, right?
We can see your full slide, sir.
Very good. Okay, good afternoon. Yes, my name is Peter Vasiliev, and thank you for introducing me. I represent company NeoZeo, and today I just would like to present our product related to biogas upgrading to produce biomethane. I'm not sure about the audience at this moment. Let me tell you a little bit background about our company and define some terms which I'm going to talk about. NeoZeo is established in 2010, and it was spin-off from Stockholm University based on innovations on porous materials. Porous material is, for you who don't know, it's a kind of sand, but each grain of sand has many small holes. And the surface area of 2 grams of such material can accommodate, for example, carbon dioxide, the same amount of carbon dioxide as a football field. More or less 2 grams of porous material which we are working with can absorb or accommodate the same amount of CO2 which can absorb on the surface of football field. Right, then if we look at our title, Biogas Upgrading Model, and for you who are not familiar with word upgrading, that means enrichment. Urban Fredriksson, just before me, presented you equipment which can convert organic waste to raw biogas. I call it raw biogas in order to distinguish it from biogas as biomethane. Well, upgrading means, because the typical raw biogas consists of carbon dioxide, mainly carbon dioxide and methane. An upgrading process means removal of carbon dioxide and increasing amount of methane as an end product. And we all of us call it biomethane because it's produced from biogas, from organic waste. And another type of methane is natural gas, which is fossil fuel and can be received from underground. Right, and what we are working with, as you know, there are many different companies and farms already converting different type of organic wastes to raw biogas. We are collecting vegetables, fruits, waste, food waste, sewage sludge, animal waste, and just normal agricultural waste like corn, silage, and other type of organic which grown on a field. Even cane sugar is very popular in India. And such organizations converting it to raw biogas, which is typically converted to electricity and heat. Our company and our vision is that converting raw biogas to electricity and heat is not economically feasible, and we promote that such companies and future potential buyers of facilities for production of raw biogas should consider already now converting raw biogas to biomethane. And until now, it was a challenge to economically upgrade or enrich the raw biogas to biomethane on small and medium flows of raw biogas. And that's why we, NeoZero, focus on small and medium volumes. And small and medium volumes are corresponding to 50 or 200 cubic meter per hour of raw biogas. And a typical farm would produce approximately 100 cubic meter per hour of raw biogas. And NeoZero offers a model, like you can see on the slide. It's kind of container which contains all our equipment, which can be placed next to raw biogas production facility, and you just plug your flow of raw biogas to the container, and outside of a container you would get biomethane. And biomethane is then can be compressed to 200 or 250 bar for different purpose. One purpose is to store the biomethane for different use, or it can be directly compressed to vehicles, cars, buses, and trucks, and even tractors. The advantage of such kind of solution is that it can be delivered to any part of a country around the world without roads, and a local producer of raw biogas from organic waste can produce local vehicle fuels independently from any kind of natural disasters, or independently from country's infrastructure. For example, without any roads, without any access or to possible natural resources like fossil fuels, diesel, benzene, or natural gas. Here I put in a slide to explain what's advantage, economical advantage such people can get. I don't put a price costs at this moment, because each country has their own, or even each part of a country would have their own cost and final price for electricity and gasoline. But you could see the top line where 2 cubic meters of raw biogas can be converted to equivalent of 1.32 liters of gasoline. Means if you can use 2 cubic meters of raw biogas as 1.32 liters of gasoline in your car. And then if you know the price of gasoline on your market, you could understand what revenue you can get to convert 2 cubic meters of raw biogas to 1.32 liters of gasoline. The second line is showing that 2 cubic meters of raw biogas at the same time can be converted to electricity, and it's only 4.2 kilowatt of electrical energy. And again, you can calculate easily what would be your revenue if the same amount of raw biogas can be converted to 4.2 kilowatt of electrical energy. and definitely you could see a big advantage converting 2 cubic meter of raw, economical advantage to converting 2 cubic meter of raw biogas to 1.32 liters of gasoline compared to 4.2 kilowatt of electrical energy. Our technology is based on a well-established technology called pressure swing adsorption technology. You can see at the top PSA, which corresponds to pressure swing adsorption, and it's a type of 2 high pressure vessels where inside we place our innovative, efficient, volume efficient adsorbents. Remember I said at the beginning of my presentation that such adsorbents has a very high surface area and can adsorb quite an enormous amount of carbon dioxide per gram. And we use that property in order to separate carbon dioxide from methane. More or less, when we push a gas through such a column, carbon dioxide would be stopped by the adsorbent, and at the other side of a pressure column we get a pure methane. All this equipment is inside of a container, and a picture of a container model, PSA model, is showing on the right side of a slide. And PSA technology was developed in 60s and 70s mainly to overcome a problem with a cryogenic technology which was used until 60s and 70s in order to downsize plants around the world to produce pure oxygen, pure nitrogen, and carbon dioxide. For example, pure oxygen is produced using PSA technology in hospitals. And you can understand that the main advantage of PSA technology is it can be used economically on small scale. Second advantage of such technology is it's compared to potential other technologies for biogas upgrading is that it doesn't use any water. It's only porous material which is solid, and it does not use any other chemicals, liquid chemicals like amines. Here's a second slide again regarding PSA technology, where you can see on the left side raw biogas going inside of a column, carbon dioxide is adsorbed, and when we get biomethane on exit, which can be used as a biomethane fuel for cars, buses, and trucks locally. Advantages. For example, if you are a producer of raw biogas, you will definitely get extra profit compared to production of electricity. You can use the produced biomethane for your own tractors, trucks, and buses. And if you are still interested to produce electricity, then you will get advantage to store biomethane and utilize that biomethane in more efficient way. For example, if during night you don't need electricity, then you can store the overnight the biomethane and utilize it during a day where the use of electricity is more important for your business or for a local community. Another advantage is, of course, environmental advantage, where you don't need to deliver fossil fuels to your local community. You can be independent from fossil fuel, and you save environment by not polluting it with burning fossil fuels. And for distributor, if someone of you is distributing fossil fuels, it will be advantage because you will reduce the transportation cost for fossil fuels, and then you will get more vehicle fuels to the local customers. And of course, environmental advantage. I believe that every business will get quite substantial benefits, not only maybe marketing point of view, but also economical benefits based on environmental advantage. Here I placed, I'm not sure how many of you are engineers, but I decided to place a simple process diagram where we can follow. You can start from the bottom. You can see there is a gray picture or where you see raw biogas, and it's mean NeoZero is not focused on equipment to produce raw biogas. There are different companies available, and one of our partners, for example, ED Biogas, who provides such equipment. And if you produce raw biogas at your area, then you need to dry it, and then you need to remove H2S, hydrogen sulfide, in order to process the raw biogas to produce biomethane. Then raw biogas going out from the production facility, and when it goes to the dryer, when it goes to the H2S filter, then it should be compressed, and then it should be cooled. Means we need to use a chilled raw biogas which should be dried to a low dew point of approximately 3 Celsius, and then raw biogas after the low pressure compressor and a cooler would go to receiver in order to reduce the fluctuations of pressure, and then the gas will main part of a model which is reading columns or vessels. Then carbon dioxide is captured, and the traces of water are also captured inside of that unit, and when we analyze the outcome of grading unit, which is biomethane, in order to confirm the quality of biomethane. It's not shown here, but we analyze the gas at the entrance after drying H2S filter and after the upgrading unit. More or less, we control the quality of inlet raw biogas and outlet biomethane. Then we should come back to the place of analyzer when the biomethane going to receiver in order to provide a continuous work for a high pressure compressor which compress the biomethane to the storage or biomethane storage, or directly to a vehicle using dispersing hoses or dispersing unit. More or less, it will be like a distribution station for your local vehicles, which will be run on biomethane. I mean, our team, our expertise is mainly on porous material. We continuously working on different innovations and improving our porous materials, which we are utilizing inside of our pressure swing adsorption unit, production of biomethane. And our expertise lies on Professor at Stockholm University, Leonard Bikström, Nicholas Hedin, who runs projects on porous material with researchers at Stockholm University, for example, Zoltan Basic, Ocean Cheng, and Panagiotis Krokidas. Also, we have a professional people who help us to expand our activity on business level, who is Thomas Arcadius, and our investors who are not written here. It's in Primacia Capital. And we have also researchers and engineers in Latvia. And these researchers at Riga Technical University working on the improvements of our technology. and in parallel development of different other parts, more engineering parts, not relating to porous material. And we have a strong network in Sweden in the field of renewable energy and waste management. And we have a very deep knowledge on porous material for different applications. We have received substantial recognition in Europe, in Sweden, and in Latvia. We have cooperation projects with Institute of Agricultural Institute and Milieu Institute. And we have cooperation with Swedish University of Agricultural Science and, of course, Energy Agency, who support us to present our equipment in India. Right. Then that's all my presentation. I hope you understand some of it. If you have any questions, you are welcome. Thank you.
Thank you, Dr. Peter, for the presentation. We have our first question here. The question is, what are the methane losses in this method during regeneration?
The methane losses will depend on quality of biomethane or a quality of raw biogas which you supply. And I mean, if typical raw biogas production plant used to have some air inside, and air is a mixture of oxygen and nitrogen, and then in a way that would provide higher losses for biomethane. But again, losses does not mean that we will just throw it to the atmosphere. Losses means we will definitely handle it with burner. And at the same time, losses corresponds to your costs. More or less, the more number of columns would be placed at your facility, the more pure biomethane you will get, and at the same time less losses you can achieve. When I would say at this moment the losses can be from 1 to 3%.
Okay, thank you, Dr. Peter.
Depends on the interest of final application.
Okay, thank you, Dr. Peter. The next question is, what are the pressures on which the system works?
The pressure, it's I would say technical details, and we have a pressure, working pressure above atmospheric pressure, and at the same time we work both at vacuum to clean the columns. I would say, unfortunately, I cannot say exact pressures just to avoid disclosing too much technical information. Yes.
Okay, thank you, Dr. Peter. And the next question is, up to what percentage can the methane be upgraded?
The methane can be upgraded. Again, it depends on the quality of raw biogas. If quality and percentage of methane in the raw biogas. If I can make an example only, because again we should define the quality of raw biogas specifically on site. But if the quality, if it's only 1% of air present, for example 0.2% of oxygen, then the rest is nitrogen, and 1% of total, and it's about 60% of methane, then the quality of biomethane will be above 97%.
Okay, thank you, Dr. Peter. The next question, Dr. Peter, it's what is the maintenance cost of this equipment?
Yeah, that's it's a good question, but at the same time it's a difficult question. It depends on what kind of equipment. Of course, we can suggest equipment, but it depends on our end customer if we would like to use a cheaper equipment or if we would like to use a more expensive equipment. Equipment means mainly compressors, vacuum pumps, and filters. And depends on that particular parts, the maintenance cost come to in place. We would definitely recommend to use more expensive equipment, but we of course are interested to understand the goal and the interest of a customer, and based on such particular interest, we should plan economically what equipment should be utilized for a particular case. Yeah, that's my answer. Again, it's general, I understand, but at the same time, I mean, we cannot say what our maintenance costs just based on general information. We need to know details. Okay. And then we need to know how much H2S you have, if you have any selectants inside, what is the content of methane in raw biogas. We need to know details.
Okay. Thank you, Dr. Peter. The next question is related. What maximum ppm of hydrogen sulfide can work with near-zero equipment?
We consider we need to clean it down to 10 ppm or below, I would say.
Okay. Thank you, Dr. Peter. The next question is, what is the life of the adsorbent and what is the energy needed for the operation?
Life for adsorbent is at least 4 years. Depends on, again, quality of biomethane, which will be raw biogas, which will be supplied to the model. And energy consumption, it will again depends on which energy consumption. If it's only for purification, when it's one energy consumption. If it's for compression of biomethane, when it's another part of energy consumption. Then another energy consumption is a purification of raw biogas, where it depends on how much energy it will be consumed at preliminary stage for filtration of raw biogas. And then everything will depend on the flow, I would say, because the flow will define if we can increase or decrease energy consumption.
All right. Thank you, Dr. Peter. The next question, Dr. Peter, is for a flow of 150 cubic meter per hour of raw biogas, what would be the utilities required? In terms of in-house power consumption and hot water, what would be the utilities required?
What size? Could you repeat again?
150 meter cube per hour of raw biogas flow.
150, right?
Yes, sir.
I would say the requirements are quite simple. The most important that the container should be placed in the area with a good base. It should be a good ground under the container. It's not necessarily concrete placement, but it should be stable. But it should not be. The container should not sink into the ground. And then, of course, if you have any natural disasters, you should consider that. If, for example, if you have a floods or other type of natural disasters, then we should probably put it above a potential flooding level. As I said before, in principle, we don't require any water supply. If you don't have water supply, we don't need it. We can avoid it. Only electricity, but electricity is just a standard plug. But again, I'm not probably in India. You have different standards. We have not constructed any plant yet in India. probably we need to address that particular question in more details. I mean, electricity connection in India.
Okay, thank you, Dr. Peter. The next question is, what is a typical payback period considering Swedish conditions in Swedish installations?
In Swedish condition, if it's, again, it depends on the size, but let's assume we have 100 cubic meter per hour as standard equipment, which we have, because of course there are different possibilities, but let's assume it's a standard 100 cubic meter equipment, and payback time would depend again on the cost of raw biogas. In Sweden, we have a very diverse cost for raw biogas, and it's difficult to answer because we need to define what is the price for raw biogas again in order to define what is the payback, because and what is a final price which distributor can pay for biomethane. It's also important. But of course, the targeted, from our side, targeted return on investment is 3 or 4 years. But you understand it's more complex. Again, it's many factors which should be considered. And if there are any interested customers in India presented at this meeting right now, we should really spend the time and calculate the economics and where the cost of raw biogas should be taken in account, and where end customer should be taken in account more or less how much we are prepared to pay for biomethane. But the simplest way is where you have your own vehicles, when you just replace a fossil fuel, and then all the revenue comes into your pocket.
Yes, Dr. Peter. Next question, Dr. Peter, is how many units of power would be required to upgrade the raw biogas of 150 cubic meter per hour?
Our standard model is built for 100 or 50, 100 or 120. 150 we have not addressed yet, but I need to check it if the equipment is available specifically for 150. I don't have information in front of me. I need to talk to our engineers first. When in a way 120 cubic meter is inside of a 20-foot container. I'm not sure if it will be enough space for equipment which will be appropriate for 150. That I need to verify. If you have a specific request, please contact me via email.
Okay. Thank you, Dr. Peter. And what will be the power consumption for a typical 100 cubic meter per hour?
And which part? Because there are at least 3 parts. I mean, purification of raw biogas, upgrading, and compression of raw biogas.
It's purification and upgrading, sir.
Purification and upgrading, then it's about yeah, it's a good question, but I usually look at my notes, but I guess it's about 1.8 or from 1 to 1, no, probably 1 kilowatt for 1 cubic meter of biomethane.
Okay, sir. So, Dr. Peter, the next question is, what kind of a partnership model are you looking at in India?
Right now, we are looking for a professional engineering company which can help us to implement projects in India. in different regions of India, because right now we don't have knowledge on installation of equipment in India, and we prefer to have a cooperation with a potential Indian engineering firm. We have already one potential engineering firm which can help us, but we are looking for other type of, not other type, but additional potential engineering firms which can market our product and at the same time have a power and knowledge how to for installation of similar products. Similar products can be, for example, engines to convert raw biogas to electricity or power or heat, and or for example, installation of raw biogas production facilities. And second, of course, we are looking for customers, and customers means people who are interested to convert raw biogas to biomethane together with NeoZero, and we are open for discussions. Discussion means we have a good knowledge and on investors who could co-invest together with potential owners and co-own these plants. That depends on a potential customer, if you would like to own the plant or if you would like just to co-own the plant. But then two categories. One category is engineering firm with a potential interest to for installation of our units and sales of our units. The second category is potential customers.
Okay.
Who
Thank you, Dr.
Can own fully or co-own such upgrading plants.
Right. Thank you, Dr. Peter. The next question is, are you planning to manufacture any of the components in India?
We would be very interested to manufacture, but right now we don't have a good knowledge on manufacturing expertise in India. It will depend on how quickly and how many customers would be available in India. If it will be many, then definitely we are very interested to manufacture. But we are not going to establish manufacture before we get a clear picture and get first orders from our customers.
Right. Thank you, Dr. Peter. The next question, Dr. Peter, is the product from your equipment equivalent to commercial CNG?
Yes, you mean like for biomethane after upgrading?
Yes, sir.
If raw biogas is upgraded and if we produce biomethane, then biomethane has the same quality as natural gas, yes. Or CNG, because CNG corresponds to compressed natural gas. And when we call it CBG, compressed biogas. And more or less when we compress it, then it's similar to compressed natural gas. I mean, equipment at inside of vehicles can be the same, which can run on biomethane, compressed biomethane.
Okay. Thank you, Dr. Peter. The next question is, the automobiles designed for compressed natural gas, can they be replaced with compressed biogas?
Exactly. You can easily replace it with compressed biogas.
Okay. Without any constructional changes in the engine?
No, no.
Okay.
No modifications, nothing. You don't need to do anything except you just need to produce biomethane from raw biogas. Because our equipment, the high-end equipment, we produce high purity biomethane. But of course, as I mentioned before, the important part is the quality of raw biogas. Means the raw biogas should have a good quality.
Right. Thank you, Dr. Peter. The next question is, what is the total percentage of initial cost is the maintenance cost annually?
Right. It's quite similar question to what I heard before. maintenance cost is a difficult question because it depends on a customer. I mean, we prefer to work with a customer as a partner where we would develop a clear financial strategy for where all the issues would be addressed. I mean, lifetime of each part of equipment, maintenance for each part of equipment, and potential benefits from each part. We have a broad suppliers for each part, and we need to address particular case in details. I would, for example, I can give you a simple example. We can supply our equipment with a low pressure compressor based on oil, and we can supply similar equipment based on oil-free. I mean, in the long term, in the long run, oil-free compressor is better because maintenance cost is very low, but the first investment is very high, and it depends on the buyer or customer what is their interest. Do we want to run at least 10 years of equipment, or do we want to run only 4 years equipment, or if they want to run it 30 years? More or less, if they want to replace their compressor after 10 or 15 years and to buy a new one, or if they want to risk more, but at the same time maintenance cost will be lower, much lower for oil-free, and then also the consequences for and lifetime for adsorbents will be lower. But again, equipment or like a compressor cost is much higher compared to oil-based compressor. Again, we are open to discuss details. If there is any very interested customer, we can address their interest and investment potential, and then also return on investment is also important part of it.
Right. Thank you, Dr. Peter. The next question, Dr. Peter, is what different types of consumables or auxiliary will be required for NeoZeo package?
Unfortunately, if you could repeat, I know it's not completely clear your question.
Yes, sir. What are the different types of auxiliary equipment or consumables required for NeoZeo package?
Okay. Maybe I can come back one. Do you see my slides yet? Right.
Yes, sir. We can see your slides.
For example, when I went through the equipment, I mean, you can see if we get a raw biogas, first we need to dry it. The dryer is simple. I mean, we don't need to replace anything. H2S filter, we need to replace adsorbent material inside of H2S filter. And how often we should replace it, it will depend on amount of H2S. The cost will be calculated based on how much H2S is in raw biogas. I cannot tell you exactly what's the current cost, because we must know a particular number of H2S over a year, not only during a particular day, but we need to have an average understanding of what's going on with the quality of raw biogas regarding H2S. If you would have other contaminations, for example, siloxanes, if you produce your raw biogas from sewage sludge, or at least you put part of sewage sludge, usually have a quite substantial amount of siloxanes, then we need to consider that additional filter for siloxanes, and once again depends on what is the amount of siloxanes over a year. When you have a before dry and filter, I didn't put it here, but there is an additional blower which consume oil. We need to put we need to change the oil. Then there is a low pressure compressor. As I mentioned before, it can be oil-free or based on oil. Then you need to replace oil, and then you need to replace some parts, or like in a car, you need to have a maintenance for the compressor, and for both, for the compressor and blower. And if you look at the top high pressure compressor, it's the same situation. You need to have a maintenance, and during a maintenance you need to replace certain parts. Depends on which compressor you choose. Cooler, it's but cooler here it's also includes filters. And filters, for example, if it's oil-based compressor, then definitely you would have an oil filter which should be replaced, plus a particular filter, and two filters, one for bigger particles and the second one is for smaller particles. And then vacuum pump, it's also you need to replace certain parts like in a car and replaced oil. Then adsorbent, at least once, not at least, but it depends again on the compressor and how careful you are with supply of raw biogas. It should be replaced once in 4 years. And analyzer is mainly working fine, but you should have a person who would recalibrate it. And then high pressure compressor I have mentioned already. Cooler, yeah, it's sustainable using electricity. Then compressed biomethane storage, it's cylinders. There are different types of cylinders available, and we can also discuss it, at least 3 types. It depends on if you would like to have a fixed type of storage or if you would like to transport it. Again, for transportation we would strongly suggest to utilize a lightweight vessels. They are much more expensive, but they would save quite a substantial amount of cost because weight which you carry on a truck would reduce consumption of fuel and increase amount of biomethane transported. Yeah, that's my explanation at this moment.
Thank you, Dr. Peter. Participants, I request you to type your questions in the chat box below.
My questions?
Yes, sir.
Interesting. Since I don't know the audience, I don't know what to ask you. It would be good to understand what type of people are presenting right now and listening to my presentation. But you all probably know that we are coming to India at the end of October, and we'll be presenting in 3 different cities. I'm very happy to see you and meet you in all these 3 cities and discuss in more details. And then if I know you in more person, we can discuss our questions.
Yes, Dr. Peter. Participants, in case you have any further questions, you can type that in the chat box.
I think we are fine. I mean, I'm okay. We just can proceed. If any participant has questions, they could interact with me via Innovation Accelerator web page or directly via email. And definitely, I'm very happy to arrange special meetings, maybe outside of our standard schedule, which will be from the end of October till beginning of November. More or less, if you would send me your request for meetings ready now, today or tomorrow, I still can devote a particular time for you. Maybe visit your raw biogas production plant, for example, or visit your experienced team if you're an engineering company. Because I would prefer if we would have a more specific interaction where, because we like to work with the people, we would like to see the people, we like to see the teams of people, we would like to see real people, we would like to see a real problem, we would like to see a real construction of the facilities of raw biogas. That's why probably you can get the information about our schedule, standard schedule from Sandeep or Michael, and when we will tell you our schedule, you can send your request for additional meetings.
Thank you, Dr. Peter.
Thank you everybody. Thank you, Dr. Peter, for all the good presentation and the kind of knowledge you have shared with us, that we can concentrate our biogas and we can use it as a commercial fuel. Now